So here's the introduction to organic chemistry. So the very slim of it is that organic chemistry is the study of one element and one element only, and that's going to be the element of carbon. Now, if you ever decide to go to college and take the organic chemistry class, it is delivered over the course of 2 semesters, which is a full college year. And the reason being is that there are so many different combinations that carbon can make and so many different reactions that carbon can make that you have to dedicate a full year of your college education to doing Organic 1 and Organic 2. So for Introduction to Chemistry, which is what you're taking in high school Regents, take a deep breath. You only have to know a fraction of it. But the things that you do have to know are very, very important. And you can pick it out because it's in fact bold. So the cool thing about a carbon atom, which makes it so miraculous in combining with anything and everything that it touches, is that it has 4 valence electrons. And those valence electrons give carbon its character. So most of our biomolecules, like carbohydrates and proteins, are made up of carbon. We are carbon-based life forms. So carbon without it, we would not be here. But back to chemistry. Okay. Can form 4 covalent bonds. Now this is important because carbon is hard. Carbon in one structure can be a diamond. Carbon in another structure can be graphite. So it will not combine ionically. It'll only combine covalently. So let's talk about the 3 different types of bonds that can occur with carbon. We have our single bonds, our double bonds, and our triple bonds. So structurally, when we were to draw, let's keep it with 2 carbon atoms, okay? So we would call this some kind of F if you look at one of the tables in your reference table. There are a bunch of prefixes. I think it's table O. So a single bond would look like this. But we know that carbon has to attach to 4 in total. So we'll keep it simple. Just make them hydrogen. And each one of these lines is considered 2 shared electrons. So in total, there will always be 8 in its outer valence electrons. So this has 1 pair of shared electrons between the carbon atoms. So we're just paying attention to this area right here. And the number of shared is 2. Carbon can also double bond. So in that case, we have 1, 2, 3, 4 atoms that are being shared. But we also know that they have to bond 4 times. So 1, 2, 3, 4. 1, 2, 3, 4. So in the middle, for a double bond, we have 2 pairs. And in total, that makes for 4 shared electrons. And again, I keep writing the word shared because this is a covalent bond. And that's pretty important to know. Last one is a triple bond. Again, they can have 4 covalent bonds. So this would be 1, 2, 3 pairs of electrons, and in total, 6 electrons shared. So like I said earlier, carbon is one of those neat freaks which basically can combine any way you can think of. So we could have them in chains, which is very similar to what I drew up above. It can also be drawn very similar to this, which is called the skeleton method. Okay. Each one of these etches would be a carbon. Carbon is also neat in that it can create a ring formation. Okay. Glucose fructose being a couple of them. And the network solids of carbon is basically your diamond effect. Network solids are basically cubes, three-dimensional, and again, pretty strong. Strong, covalent bonds. So talking about some of the properties that are important for organic molecules, again, you have to know that they contain the one most important element for our planet, and that's carbon. But carbon can match with anything, pretty much. It can match with oxygen, nitrogen, halogens. It loves hydrogens. So you name it, it likes it. So what you have to know is that organic compounds for you in this class is that it contains carbon and hydrogen. But the key takeaway is that it has to have carbon. So some examples, C6H12. O6, that's organic. We can say CO2. Okay. We can say CH3OH, which is methanol. Okay. Anything that contains carbon is organic in chemistry. And for the most part, they're generally nonpolar. Nonpolar in that they're symmetrical when you build them, so that you can basically find two lines of symmetry with them. Okay. But things that you do have to know to be able to answer some of the skills in your packet is that the intermolecular forces, which is your IMF, are pretty weak. Carbon can stand on its own feet without being attracted to anything else. Now, if carbon's pretty strong, in some cases, and again, if it's nonpolar, this is going to show low melting points and low boiling points. In the cases that, let's say, it is a gas, for example, let's talk about propane, one would assume if you can smell it, then it's a high vapor pressure because it has become a gas in which you can now smell. And another thing you can think of is, well, one of the examples of carbon was a network solid called a diamond. Is that soluble in water? No. So we say that carbon has a low solubility in water. So hopefully this helps with your notes. Keep your notes with you as you prepare to do Skill 1.